Okay, good morning. Welcome to
SummerMath28.
SummerMath number 28. The next section we're going to be doing in our book, which we're not going to start for a week because you guys are going to be at camp next week, is on counting with symmetries. And we've talked about a little bit about people sitting around a table.
Yeah.
And so I wanted to do kind of a slightly challenging problem today, just for fun, on this counting with symmetries. So the question is, how many different ways can 6 people sit equally spaced around a table if Tinky and Turner must sit across from each other? And remember, when we're talking about, can I use this? When we're talking about arrangements around a table, something like this, A, B, C, D, is the same as A, B, C, D.
You just shifted the table.
Yeah, eraser. That's good. Can you get an eraser?
Right.
Alright, so we've got 6 people sitting around a table. And,
Tinky and Turner must sit across from each other.
yeah, why do Tinky and Turner have to sit across from each other?
Because they don't like each other.
They don't like each other.
So, I don't think that's right. Well, you have six.
Mark that spot again.
You have 6 slots around a table.
Yeah, why do you think that's not right?
Because Tinky can go anywhere. It's just that Turner has to sit across from her.
Right, so we were just marking he was just marking the 6 spots around the table.
Yeah.
Okay, so there's the 6 spots.
So maybe you could just ignore the restrictions first.
Okay.
The Tinky and Turner have to sit across from each other.
Okay, sometimes it's good to ignore the restrictions.
I have a way to plunge in with the restrictions.
Okay, you want to plunge in with the restrictions? What do you want to do? You want to plunge?
Let's let him tell us the idea.
Okay.
So Tinky has 6 spots.
Yep.
And Turner has 3, because wherever Tinky sits... Actually, Turner only has 1.
Turner only has 1.
Because wherever Tinky sits, Turner has to sit across.
Right.
Yeah.
Make sense?
Yeah.
Okay.
So there would be 6 different arrangements for them to sit across from each other.
Okay.
But there might be some where there's like run-ins with the other people.
That's right.
Some of the people can flip.
Uh-huh.
It might be hard.
Yeah. It's tricky, right?
Yeah, we talked about a problem like this recently.
Right.
I think we...
What did we say was a good idea to do on these?
Maybe ignore the restriction.
Okay, ignoring the restrictions just says, let's do that. How many ways can 6 people sit around the table? What's the answer to that question? There's no restrictions.
6 factorial.
Well, it's not 6 factorial.
Well,
that's how many ways people can sit in a straight line.
But you have to divide it by 6 because you can rotate the table.
So right.
Yes. Because 5. A can be here, 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 here.
Right. You can always rotate the table, so it's actually 5 factorial without the restrictions. Okay. Does that help you?
Well, and now, if we come back in on the restrictions, we have to divide it. It looks like we might have to divide it by 6 again for Tinky and Turner, because Turner only has 1 spot.
Okay. All right. Let me. These are tricky problems, so let me give you a little bit of a help here. Because of the rotations, what we can do is just pretend that let's say Tinky sits up here. Okay? So no matter where Tinky sits, we can always rotate Tinky to be up there.
Yeah.
Okay, now where does Turner have to go?
Turner has to go down there.
Turner has to go down there. Okay? So when Tinky's up there, Turner has to go down there. And any way they sit across from each other, they have to we can rotate it into this position. Yep. So this is a good way to start on this. Tinky's up here because we can always rotate Tinky up here. Turner's down there. What now?
and then we just have to arrange the 4 other people.
Okay. How are we going to do that?
It's 4 times 3 times 2 times 1.
All right.
Which is 4 factorial. 20. Well, just 24.
Does that make sense?
Yeah. Well, but you said earlier that these, because now you can't rotate these.
You can't rotate these because we were fixing Tinky up at the top.
Yeah.
Okay.
So that makes sense.
All right. So now here's what happens when we look at it without the restrictions. Remember we said there were 5 factorial ways without the restrictions?
Yeah.
Because we could put Tinky up here and put the 5 people in.
Yeah.
Only 1 out of 5 of those meets our condition because Turner could either be here, 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 or here.
So
Well, only 1 out of 5 works.
So I have to divide it by 5.
So we have to divide by 5. Okay?
Yep.
All right. Good job this morning. These are tricky. This is what we're going to be talking about next week.